Okay, so let's talk about section 2.3. Section 2.3 talks about the dreaded word problems. And we start off with two kinds of problems in this section. The first kind is a mixture problem. People sometimes look at mixture problems and, like any other kind of word problem, just freeze up and think, how can we do it? So my job here is to try and present you with a strategy for coming across these kind of problems each and every single time. So we're going to talk about how can we use a table to solve this kind of particular problem, which is our mixture problem. We've got a coffee merchant who wants to make 9 pounds of a blend of coffee that can cost $6 per pound. Now the blend is made using $7 grade and a $4 grade of coffee, mixing those two together. So how many pounds of each of these grades should be used? This should make some sense to you that the cost of the coffee that we're going to mix up is going to be somewhere between the higher cost and the lower cost of coffee. So the question we want to ask is, well, how can we use this table to help us out? Well, let me describe what's going on right here when you're looking at this table, and then we'll make one of our own for the next problem. As you can see right here, we've got along the top row an amount times some cost per pound. And that's going to give us our value. Now, this is a formula that they show in the textbook, but what we want to look at is that we want to say, well, if this is an amount, how many pounds, right? You can think of it this way. If we take the amount, right, let's say in pounds for a certain type of thing, and we take the cost per pound, right? So we take cost per pound, right? What are we left with? Well, this is a cancellation of our units, pounds, those cancel out in this fraction, and that's just going to leave us with cost. And that's kind of what's going on right here. As you look from left to right, we're actually saying along each row you multiply. So if we take the amount of pounds, x pounds, times the cost per pound, $7 per pound, x times 7 is going to give us 7x dollars. That's how much we'd have to pay. We're going to add to that a 9 minus x pounds. How do we get 9 minus x? Well, it was 9 pounds. That's what we want to make as our total. And if we're saying, well, we don't know how many pounds of the $7 we're going to use, but whatever it is, we're going to take that away from the total 9 pounds that we're going to get. So if we get 3 pounds up here, we're going to take that away, we'll get 6 pounds here. So our total pounds, 9 minus x pounds times 4 pounds, is 4 times 9 minus x dollars for that amount of coffee. How much did we end up with? If it's $9 pounds at $6 per pound, we're going to end up with 6 times 9, which is 54. So what do we do with all of these if we want to use this to solve our problem? Well, essentially, we're saying that in this value column, the total cost of the mixture should be equal. In other words, everything that we've cost, everything that we're buying right up here, we should say, well, whatever the cost is for A plus whatever the cost is for B is going to give us our total cost, which should make sense. So let's take that. That means that we're going to say our problem setup is actually like this: 7x dollars to the $7 grade pound per pounds times x pounds, right? Plus 4 times 9 minus x dollars is going to give us a total of 6 times 9 dollars for the total mixture. Well, now this is a nice equation that we can solve. We know how to do this. 7x plus, distribute our 4. 4 times 9, 36, minus 4 times x equals 6 times 9, $54 altogether. Well, like any other equation, we should combine our like terms. So we're going to get 3x plus 36 will equal 54. So we want to gather all our constants to the left-hand side. We're going to subtract 36 from both sides. Subtracting 36 from both sides. We end up with 3x equals, the difference between 54 and 36 is 18. So if we divide both sides by 3, we find that x equals 9. Well, this is good This is what we wanted. We isolated x, but remember, it's a word problem. And if you've got a word problem, this algebra that we've just done is nothing more than a tool. It is not the answer. What is the answer? Well, the question was how many pounds of each grade should be used? Well, we used X pounds for the $7 grade, so that means at $7 per pound, we should choose 9 pounds. Good Lord, look at that. At $7 a pound, 18 divided by 3 is, of course, 6. We should use 6 pounds of that. It's much better. At 9 minus X pounds, that's $4 per pound. Right? That means we're going to take 9 minus 6 to give us 3 pounds. Right? So we're going to use 3 pounds of the $4 per pound, 6 pounds of the $7 per pound, and that's going to give us a total of 9 pounds. Right? So this would be how much we're going to use right here. Okay, so that's our answer. That's what we wanted. Make sure that you always use the correct units when you're answering a word problem like this to make sure that you understand we're answering the actual question being asked.